Okay, welcome everyone. This is the week 3 webinar of the online statistics class. And kind of what we're planning today is, as always, I'll answer any questions you might have. And then we're going to move on. We have two chapters, chapters 3 and chapter 4 and chapter 5. So chapter 4 talks about discrete and continuous variables. So I'll review what those mean. That was also in the earlier chapter, first week, and but you might have forgotten, so I'll talk about them again. Then we'll talk about a probability distribution table. So given some information about probabilities, how do we make a probability distribution table? Then we'll talk about the expected value and the standard deviation based on a discrete random variable. Then we'll go into the binomial distribution, which is when you have a yes/no type question. And we're going to be looking at probabilities based on the yes/no type question. Then we'll look at continuous distributions. That's the chapter 5. Okay. I know it's two chapters, but they're not too bad. It's not usually what everyone complains about. That's one reason I put them together. So continuous distributions, we, again, I've talked about it, but now we'll get into more detail. We'll talk about, it turns out most continuous distributions, the math is way too hard for anyone that isn't a math major to be able to do. But there is one that is not too bad. So we're going to look at the one that's not too bad, and that is the uniform distribution. The one math that you have to remember, it's very simple, is you have to remember the area of a rectangle. And once you can do that and a little basic algebra, then you should be able to handle the uniform distribution and probabilities based on it. Then we'll get into the mean and the standard deviation of a uniform distribution. So that becomes really important. I just want to remind you that this is week 3. 3 is an odd number. You might smile. How come? Yeah, no exam this week. So no exam. Maybe you're saying, oh, I love the exams, but my guess is not everyone loves exams. But there's no exam this week. But what I do recommend, especially when there's no exam, because that means you got a little extra time, is really work on your project. I'm not seeing very many of you, or if any, um, post on the project discussion forum your idea for the project, your survey question, who your client is going to be, and how you're going to conduct your survey with what method. If you can put that on, if you can post that on the Project One discussion board, I'll let you know if that'll work so that you can continue on to the next step. The hope is by yesterday you do that, but no one did. But hopefully you'll do it really soon. Because again, do not wait till the end to do your project. It's not a short project. Make sure you give yourself time and work together with partners. That's really important. So, are there any questions about anything that involves this class or anything else? Any questions? Okay, just want to let you know I'm always watching the chat box. So if you have questions, you can post them in the chat box anytime, and I'll do my best to answer them. And hopefully it'll go well. I'm also in my student hours, 4 days a week, not tomorrow, but Monday, Wednesday, Thursday, and Friday. And always happy to answer questions that way too. And if you have any personal questions, you can email me. If you have any general questions that aren't about the project, that just about how to do a problem, for example, that would be more of a Q&A. But make sure you do ask questions when you have them. Okay, who remembers the difference between discrete and continuous variables? I know it's been 2 weeks. We talked about it. But do you remember the difference between discrete and continuous variables? If you remember, one thing I can let you know, they're both quantitative. So the answers will both be numbers, but how they differ? So you want me to repeat to include one more time on the discussion? Yeah, your client, what your survey question will be, and also your sampling technique and how you're going to conduct your sample. Okay. The project, when is the project due? That one I have to go to the syllabus to remind myself because I don't have all the dates in my brain, but it's right here. So project one is October 19th. So again, it may seem like a long time, but it isn't that long because it takes time. You gotta survey people. That's gonna take some time right there. You gotta work with your partners. You want to submit it like a week ahead of time so that I can submit your draft a week ahead of time so that I can give you suggestions so you have some time to actually, fix it. So there's a lot of things that should be done. That's why I'm spending time now to tell you instead of, thinking, you just wait for the last couple of days. That won't work. Okay. So make sure you get a lot done soon. Okay. You have all the statistics information for it. Okay. I don't see anyone saying that it's discrete. Ah, here we go. Discrete is for countable quantities and variables are measurable. Yeah. Or a lot, kind of so yeah, the variables are measurable. Countable is really the word for discrete. Continuous, continuous means it's not discrete, so that means that it's going to be like a full interval, including every fraction in between. Okay, and it could be all possible numbers. Okay, whereas discrete, you can list the numbers, and that's the most important thing. List them. You can put them down in a chart. Okay, so that's important instead of with continuous, you can't list every possible number. There's too many of them. Okay, it's an far infinite amount. Okay. So here's a reminder. A discrete variable is a quantitative variable whose set of outcomes can be displayed as a list. Quantitative variables that are not discrete are continuous. Okay. Does that make sense? Okay. And here's a big deal for this week. And that is for a discrete variable, we can create a probability distribution table. Okay. You can make a table where you have, say, the the rows are all the possible outcomes. Okay. Or you can do columns are all the possible outcomes. That depends on how much space you have on your paper, but basically you can list the outcomes. Does that make sense? And I'll give you lots of examples. You'll see them. So we'll see the difference, but it's really important you get that down so you know what type of thing you need to do with them. So in grammar, if you could say how many, then it's just then that's kind of discrete. So it's like how many how many people are in the room? Okay, you could list. It could be no people, zero, one, two, three, four, five, six, seven, dot, dot, dot. I don't know. Maybe the room fits 75. So till 75. You can list them all. In our class, when we draw a table, I won't make it that big, but it might be one, two, three, four, and five. Okay. So that's discrete. Whereas continuous is how much. So it'd be like, how much do how much time did it take to take a shower today exactly? Okay. You can't list all the possibilities. Okay. It goes on forever. Okay. I took my shower. It took 6.1357216579378 dot 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 minutes. Okay. Does that make sense? So that would be continuous. Okay, so now that we have that, what we want to do is we want to look at things you can do with discrete variables. And the first is we can create distribution tables. So let me give you an example. Okay, I like this example. One is it's the kind of thing that happens a lot. Doesn't have to be a car salesperson, but lots of different things. So a car salesperson gives out a $10 gift to every customer who's test drives the car. Okay. And that's typical, by the way, because what you want to do is you want people to come and test drive the car because if you don't give them a gift, you don't give a gift, then you probably won't have very many people come. It gets people to come. Does that make sense? So it's really important to understand that kind of thing. Okay. So Advertisement's the same way. You pay for advertisement because if you pay for advertisement, you're more likely to have more customers. Same idea as giving a gift. Okay? Let's suppose that 12% of all customers who test drive a car purchase a base model of the car, resulting in $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in $300 commission for the salesperson. Okay? So what do you think? Do you think this might be a good job to be a car salesperson if this is what you get? What do you think? Does it sound good? Okay. Let's suppose it takes 20 minutes to work with someone to do the test drive. Okay? On average. Okay? Is it a good job? Are you making good money? How do you tell? Any thoughts? Okay, I don't expect you to answer because that's what we're doing today. This is where you have to understand expected value and standard deviation for a discrete distribution. And it's a step-by-step process. So the first step is you create a probability distribution table. This is definitely a discrete variable because either you're going to have the person purchase the base model, or maybe they'll purchase the deluxe model. Can anything else happen? What do you think? Yeah, they don't buy any model. Okay. That sucks for you if you're the salesperson, but that happens most of the time. So what we're going to do is the first thing is we want to look at the profit. Profit is what matters. Okay. Hopefully you know that in business, it's profit that matters. Okay. And hopefully you remember in business that profit is revenue minus cost. It's how much coming in minus how much you spend. Okay. So let's look at the different things that could happen. One is they can end up purchasing the base model. How do we find the profit if the person purchased the base model? What is the profit? Kind of reading the question. What's your thought? If you're the salesperson, how much money are you making? Yeah, it's 190 because your revenue is $200, but you had to give them a $10 gift. So you're making $190. That's pretty good if you make that amount of money. So that's your first possible value of X, the profit. The second possible value of X is what? That would be if the person bought the deluxe model. What's your profit if the person bought the deluxe model? Yeah, so it's 300 revenue minus $10 cost. It's always $10 cost. So that profit would be 290. 300 minus 10 is 290. And then there is that final profit. What's your profit if the customer says, screw it, I don't want that car, and walks away? What's your profit? Yeah, it's negative 10 because you're getting $0 and you had to pay $10 to give that customer the gift. So it's negative 10. Negatives happen. Any questions on that? All right, now we want to look at the probabilities of these discrete items, these possibilities that could happen. What are the probabilities? So the first probability is the probability that your profit is $190. What is that probability? And the hint is all you have to do is read the question and it tells you. Yeah, 12%. But I want to let you know you don't want to use percents. You want to use decimals. So it's going to be 0.12. We're going to be doing math. And when you do math, you can't use percents. You have to use decimals. What's the probability of profiting $290? Yeah, that's 0.08. So don't forget, you got to move the decimal over twice. The first is zero point 0.8, and then you got to stick a zero in to get the second move over, and you get 0.08. Okay, now if we want to find out the profit of negative $10, what's its probability? What we do is we say, well, the total probability is always equal to 1. Okay, so what we can say is 1 is equal to 0.12 plus 0.08 plus the probability that x equals negative 10. Any questions on that so far? Okay, 0.12 plus 0.08 is 0.2, right? 12 plus 8 is 20, 20%. 0.2 plus the probability that x equals negative 10. Anyone lost on what I just did? And note that that was equal to 1. We'll just put it there again. So now what I do is I subtract 0.2 from both sides. And 1 minus zero point 0.2 is 80% or 0.8. Any questions so far? Was that too fast or are you following? Oops. Any questions? Okay, so now that we did that, what we're going to do is we're going to organize this. And the way you organize this is you put it into what's called a probability distribution table. And here's what it looks like. It's a table, and the first row are the x's, and the second row are the p of x's. If you can also make them columns instead of rows. That just depends on what fits on your, on your paper, okay, or on your screen or whatever. Here it fits better to be horizontal. Sometimes vertical is better. So I'm just going to write down the x's. 190, and then 290, and then negative 10. And then I'm going to write the probabilities, which is 0.12, and then 0.08, and then 0.8. This is called the probability distribution table. So it shows really how this discrete variable works in terms of its values and its probabilities. Any questions at all on what I just did? Okay. Again, you're going to have to do these things, so make sure you know how to do it. All right, so now here is the question. We want to see, is this a good job? How much money do you think this job is going to pay? And what we want to do is let's do, instead of per hour, let's look at per customer. Okay. Obviously, it's going to be different depending on the customer. But if you think about this person who is selling cars, if this person has, like, every day has a bunch of customers and maybe works for months and months, there's going to be hundreds and hundreds of customers. So what matters is over the long run, after many, many, many customers come in, what is the average profit? Any questions on that? Per customer. Okay. And that average profit is called the expected value. Okay. It's the average value in the long run that it's likely to be. Okay. Any questions on that idea? So let me give you the template on interpreting the expected value. And here's what it is. And you got to listen carefully. It says, if many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Did you hear me scream? Okay. Don't just laugh. There's a reason. Okay. I need to tell you something. Okay. If you didn't hear it, then you could at least see it on the screen. Okay. And I highlighted it out. All right. If you don't have those words when I ask you to interpret the expected value, then I take a lot of points off. And I want to let you know that AI won't give you those words. Okay. So there's a bunch of ways I kind of get you if you're using AI to do all your work. Okay. You need to learn this stuff. Okay. So those words have to be there when you're asked to type out or write out the interpretation of the expected value. Does that make sense? Okay. So now let's find the expected value. So just to let you know, here's the formula for expected value. It's actually the sum of x times p of x. Okay. It's also called the mean, mu, but usually with discrete variables, we call it expected value. And there's also going to be a standard deviation too. Okay. Now you could do it. The math isn't that bad, but there's an easier way. Any guess on what the easier way is? Yeah, we use a calculator. I made the calculator, trying to make this class easier that way. So we're going to go to this calculator, and I tried to make it really obvious. What calculator number do you think you should use? It's not a trick question. Yeah, number 7, expected value and standard deviation. Okay. So not only did I try and make the words very clear, I also put it in the order at which we do things in this class. So I click on that. Okay. And just let you know, it was a little easier to do using columns instead of rows on the computer, so I did it that way. Smartphones tend to be kind of longer, for example. So that's why I did it that way when I coded. I coded all this. So if you ever find a mistake, let me know. So it asks you to put in your x's and your p of x. It says enter the outcomes of the probability of that outcome occurring and then hit calculate. Leave the bottom rows that do not have any values blank. Do not include commas in your entries. And that's really important. Computers can't always deal with commas so well. So if it was like 12,520, don't write 1, 2, comma 520. Just write 1, 2, 520. Does that make sense? So don't use commas in your numbers. So then we just put in the numbers. We just go up, we have a table. X's are 190, 290, and negative 10. 190, 290, negative 10. Okay. The probabilities were 0.12, 0.08, and 0.8. So 0.12, 0.08, and zero point 0.8. And I just scroll and I hit calculate. And it gives the expected value and it gives a standard deviation. So the expected value is 38 and the standard deviation is about 98. I'm going to go 98.47. Expected value was 38. Any thoughts on why I chose two decimal places? There's a reason. And it's important in this class to really understand what this is talking about, what it does. So, like two decimals makes sense in this case. How come? Could do nearest whole number, but you definitely wouldn't do one decimal. Any thoughts? I don't see y'all jumping in because this is about money, right? This dollar sign. So you could read this as $98.47. Does that make sense? So it is very important that you don't just memorize formulas or something like that, but really understand the purpose of all this. And here, in this case, for this example, it's on average how much money you're going to make and how much money you might be off by. Any questions on that? Okay, the expected value is 38. So now we can interpret the expected value using this template. Okay. And by the way, don't just copy and paste the template and don't change anything. We need to talk about what this is. So it's not if many trials are done. Now it's if many customers come and test drive a car. You see, that's what a trial is, right? Customers coming. Then it is very likely that the average profit that the salesperson will make per customer will be very close to $38. Okay. And as I mentioned, if it's, 20 minutes per customer it takes on average, is that a pretty good job money wise? What do you think? What do you think? Good job or bad job? Yeah. So you think about that would be more than $100 an hour on average. Okay. That sounds like a good job, right? Okay. But the standard deviation was $98.47. Okay. That's a pretty high standard deviation if you compare it to the mean. Standard deviation's high. There's going to be some days where the salesperson doesn't make any money. And because of that, what you need to do, and this is about strategy in terms of, your own finances, is if that's what your job is, you got to make sure you have money in the bank. Otherwise, you may not be able to eat tomorrow because you might have a day that you don't make any money. Do you see that? And then you'll have days that you make lots of money. Okay, so because for each customer, that's a standard deviation, you'll have, some customers you actually have to give them money or give them a present that costs you $10. Okay, so you'd recommend the salesperson having some money in the bank to afford basic needs for days when the salesperson loses money. This is very important in good business strategy. If you have a high standard deviation in your business, then you need to make sure that you have money in the bank. Okay. If you have a very low standard deviation, then you're probably fine without a lot of money in the bank. And that standard deviation is meaningful. Okay. On the other hand, if the expected value is, say, $1, this would be a horrible job because you'd be making $3 an hour on average in the long run. That sucks. All right. Any guess on how I've used this expected value to make a lot of money? I've used it in lots of ways, but the first time I used it. Any thoughts? Here's a hint. I was 21 years old, which is like just towards the end of my undergraduate. time in college. 21 years old. Any thoughts? All right. And I'm a mathematician. I was a card counter. And what I did is I looked at the expected value of blackjack with a strategy that I was able to use or be able to I actually came up with a strategy of card counting, a specific strategy that I used that worked really well for me. I calculated the expected value, and my expected value was about 4% profit per game. Okay. So that means I'm going to lose, and there was a standard deviation. It was probably, 40% or something. But, so I'd lose some games, but I'd play for hours and hours and hours in the casino. Any guess what happened? Any thoughts? Okay. Well, what happened for a while is I made a lot of money. Okay. I made a whole lot of money. Not billions, but I made a lot of money. And then I was told that I wouldn't be alive if I ever came back again, and I didn't come back. I'm not stupid. It was when the mafia was in charge of the casinos. Um, but I let you know that, made sense. Now I use the expected value for a different kind of gambling that the mafia, there's no evil person that will get you. And that's the stock market. Okay. And it's really important. The stock market, by the way, has a positive expected value. Okay. A much higher expected value than than putting your money in the bank. Just let you know that. Okay. Much higher standard deviation also. And we'll talk about that another week in terms of some of the calculations. So this stuff's really important. Okay. It's a good way. Making money is important. Maybe you don't care about money, but it's nice to make money. Okay. So here's another example. And this is called actuarial work. Okay. Have you heard of an actuary? Do you know what they do? Actuary. Okay, they work for insurance companies and they actually calculate the expected value for things like life insurance or car insurance or health insurance. That's what actuaries do. Okay, so it's all about what we're doing. So let me give you kind of an example. Okay, now I'm going to give you an example, but you're on the other side. You're the person buying the insurance instead of the person that is selling the insurance. Okay, you've been offered a life and dismemberment insurance policy that costs $1,000 a year. Okay, you probably all know what a life insurance is. Do you know what dismemberment is? It's depressing, by the way. You know what dismemberment is? What that word is? Okay. That would be like, you get in a car accident and your arm gets chopped off. Okay, it really sucks. Better than dying though. So you don't die, but you have some really awful, physical damage to your body. Okay. And so it's going to be $1,000 a year to buy this life and dismemberment insurance policy. Okay, the policy pays the heirs $100,000 in the event of death. Okay, and 50,000 in the event of dismemberment. Okay, isn't that typical for insurance policies? The actuaries have determined that you have a 0.3% chance of dying this year. Okay, it's a small chance. Okay, everyone could die. Hopefully you don't. Okay, and a 0.5% chance of dismemberment this year. That sucks too. Not as bad as dying, but it still sucks. Find the expected value and standard deviation. Interpret the expected value, and then explain why the standard deviation might indicate that it still might be a good idea to purchase insurance, depending on your situation at home. So now I'm actually, going to go a little faster since we've done one of these already. But I figured I'd show you this because it's kind of a nice example. So here again, if you die, then your profit is going to be 100,000 minus 1,000 is 99,000. If you have dismemberment, your profit will be 50,000 minus 1,000, which is 49,000. But if you don't die and don't have dismemberment, your profit is negative $1,000. Okay. And again, don't forget 0.3% is not zero point 0.3, it's 0.003. Always remember to move the decimal over twice. 0.5% is 0.005. Then 0.003 plus 0.005 is 0.008. 1 minus 0.008 is 0.992. Okay. You're always welcome to use a calculator. You're not expected to, do my like fancy brain calculator stuff. You're always welcome to use a calculator. Any questions on how how I found the X and P of X in the table, the values, how I created the probability distribution table? Any questions? Okay, so now we just go. I think the easiest thing to do is refresh, and that erases everything else. And then I can write 99,000. Don't put commas. And then we have 49,000. And we have negative 1,000. And then we had 0.003. We had 0.00, I think it was 5. Yeah, 0.005. And then finally we had 0.992. Any questions on entering this into the calculator? Then hit calculate. Okay, expected value is negative 450. Standard deviation is 6,495.96. What do you think? Do you think buying insurance is a good idea? What's your thought? Okay, so the answer to this is it depends. Okay, and I know some of you might have a small child. And if you die financially, it could be awful for the small child, right? So you have this giant standard deviation, which means that it still could happen. It's not likely, but it could happen. So if it's a disaster, if in terms of financially, if you die, then you probably want to buy insurance. On the other hand, if you're just a college student and you're not taking care of anybody, there's no reason to buy life insurance because you have an expected value of negative $450 on average. Doesn't help. Does that make sense? And by the way, it'll always be negative, otherwise the insurance company can't make a profit. And they want to make profits. That's what actuaries do. They make sure there's profits. Okay. Standard deviation is giant. So the way you would interpret this is if many people bought life insurance, then it is very likely that on average, their profit, or you could say loss in this case, their loss would on average be $450 per person. Any questions on that? By the way, if you buy life insurance, do you hope a whole lot of money is going to coming in? What do you think? Yes or no? What do you think? Yes or no? Okay, so if you buy life insurance, do you hope a whole lot of money is going to come in for your family? Or do you hope you lose money? Okay. So let me tell you this, if you hope that a whole lot of money will come in for your family, you need to go to a psychiatrist because that means you want to die. That's not okay. You buy life insurance hoping that it doesn't happen. Okay. So that's just let you know. You should never want to die. Okay, so let's go on. And now we're going to talk about the binomial distribution. Okay. And here's what the binomial distribution. It comes from multiple independent trials of a yes/no type question, and it measures the number of yes answers. Okay. So very important, not hard to, hopefully y'all understand what yes/no answer questions are. Okay. And they can be turned into yes/no questions that counts. So here's an example. This is one, and by the way, you might be a little depressed when you see this. Okay. There have been 175 years in recorded history in global temperatures. Okay. I looked this up, by the way, this is true. Okay. So the human race has been measuring Earth temperatures for 175 years. Okay. I looked this up and, looked at the science. Okay. So in the next 20 years, if weather is random, find the probability that at least 10 of them will be in the top 10 of the prior 175 years. Okay? So this is an example of binomial distribution because, for example, 2025, at the end of it, you're going to say, hey, was it in the top 10 of the last 175 years for highest temperature? And the answer is yes, or the answer is no. It either was in the top 10 or wasn't in the top 10. Does that make sense? That makes us a binomial distribution. And we're looking at a 20-year period. So there's 20 different years you're looking at. Any questions on this? Okay. We're assuming that everything is random. Okay. There's nothing special about the last 10 years compared to the rest of the 175 years. Okay. It's just randomly looked at. Okay. So what you need to do is you need to come up with a bunch of things. What's n in this case? What's n? It's easy if you know what to look for. There's no calculation to do. You just have to read it. Yeah, n is 20 because each of those 20 years is going to be yes, it was in the top. It was in the top 10, or no, it was not in the top 10. What's the probability that any given year will be in the top 10 of the prior 175 years if everything is random? Okay, this isn't that hard. Okay, well, how many ways are there being in the top 10? There's 10 ways. Does that make sense? Divided by 175 years. So each year has a 10 in 175 chance of being in the top 10. Does that make sense? Any questions on that? All right, so now what we need to do is we need to say, what is the probability that at least 10 of them will be in the top 10? So that's probability that X is greater than or equal to 10, that the number of yes answers is at least 10. Okay? And the probability that any individual, the probability, the lowest, for that to happen, what's the lowest number could be in the top 10 of the prior 175 years? What's the lowest? This is obvious also. 10. If there were 10, then we've had at least 10. Do you see? What's the highest? Highest would be 20. That means each year we're going to say, hey, that was in the top 10 of the last 175 years. Do you see? Number of trials was 170. Sorry, was 20. Because we're looking at 20 years. P is 10 over 175. So are there any questions on what I just did? Any questions? Please ask. Do want to let you know it's much harder to watch and much easier to watch me do it than to do it yourself. That's kind of how statistics works. All right. So I need to calculate this probability. Any guess on what I'm going to do next? This should be an obvious answer. All right. If no one knows, I'm going to use a calculator and go back to the calculator menu. And what calculator number do you think I should use? Yeah, this is number 8 because we have a binomial probability. We're looking at the probability of at least so many yes answers in a yes no question, and that's binomial. Okay. And notice it says enter the lower bound for the number of successes, the upper bound for the number of successes for the high, the number of trials, and the probability of success. Then hit calculate. And what I've already done is all the work. The lower bound was 10. The high was 20. Number of trials was also 20. And the probability, I want to let you know it was 10 over 175, but we need to write it as a decimal. So if you click scientific calculator, then you just plug it in. 10 over 175. And we get 0.05714285714. And I'm just going to copy that. I'm going to paste it into P. Any questions so far? All right. Wait, yeah, so the question is, could you do 4 decimals? You can, but for example, if this were an exam or homework, whatever, it's just as easy to copy and paste it with all of them. You might as well just do them all, and it'll give you a more accurate answer. Okay, 4 will probably be enough for the calculator, for the number of decimals you want. But hey, might as well just go for it. Does that make sense? And then hit calculate. What'd I get? 0. Okay, and by the way, this goes to something like 10 decimal places. What does that tell us? This probability is 0, which means, within 10 decimal places, there's almost no chance of it happening. Okay, and this is really important. Okay, this is why you really need to trust scientists and statisticians when you're looking at results. If anyone says we don't have climate change, they're wrong. Because if they're saying, oh, this is just random, we'll just have some warm weather for the last 10 years, the last 20 years. No, that almost can't happen. Does that make sense? Okay. If it's just kind of, well, we've randomly gotten, warm weather. That's not true. Because if it was true, there'd be almost no chance of that happening. And that's what statistics is really all about, is it allows you to say, hey, this can't happen. This probability is so close to zero, it just isn't going to happen. So then you say what must have been wrong, and what's wrong is right here. The weather is random because the weather's not random. Okay. What's happened in the last 20 years, by the way? Hopefully you all know. And this is what you do next as a scientist, not as a statistician, but after you see the statistics, as a scientist, what do you do next? Having seen these statistics, when you say, hey, there's pretty much no chance of it being random, because this is what statistics is all about, is getting this to be done. Any ideas? Okay, yeah, the next step is to look at the science. You look at the chemistry, you look to see, all right, well, if it's not random, what's happening? And what they've done is they've looked at all the different things that are possibilities. They've only really found one that that works. And that is we have a lot more carbon dioxide in our atmosphere than we used to. There's nothing else that would make this happen. And they've done statistics on all the different things that we've noticed, and nothing would make this happen. So that is what they call scientific evidence that we have climate change. Any questions on that? Okay, and this is where it's really important to understand statistics and to understand science, because it's a teamwork. Okay, you got to have statisticians and scientists together to come up with what's happening. Any questions on this? Okay, so climate change is happening. And by the way, this really is real. Unfortunately, in the last 20 years, all 10 of the last top 10 in the last 75 years have happened in the last 20 years. So there it is. All right, here comes another example. All right, this was done. There was a survey that was taken not too long ago, and they found 24% of people worldwide feel lonely. Okay, hopefully you don't feel too lonely, but you might. You get a 24% chance of feeling lonely. Okay, if 17 randomly selected people are surveyed, what is the probability? Now we're going to look at a bunch of things. Between 5 and 10 of them feel lonely. Okay. So let's see if you can tell me what the low is. Put in the chat box for part A. This is very easy. What's the low? No, 0 is not between 5 and 10. 17 is not between 5 and 10. Yeah, 5 is the lowest number between 5 and 10. It's not a trick question. What's the high? 10, because that's the highest number between 5 and 10. How many trials? 17. What is the probability that someone will feel lonely? What is B? Put in the chat box. It's all there for you. It's not 24. It can never be bigger than 1. It's a probability. So don't forget to do a little math. Very basic math. So what is it? It's 0.24. Don't forget to turn the percent into a decimal. That's necessary. Any questions on that? Okay. And we could put it in if you want. So 5, 10. We had 17 and 0.24. Calculate, and you get about a 0.3875 chance. How did I solve for P? Well, it was 24%. You move the decimal over 2 and you get 0.24. That make sense? Yeah, nothing hard there. All right. At least 6 of them feel lonely. What's the low? This is obvious. What's the low? This shouldn't be hard. What's the low? What's the low if it's at least six? Yeah, six. What's the high if it's at least six? Not, yeah, 17. At least six means anything bigger than six works, and you're asking 17 people. Trials are still 17. P is still 0.24. I'm not going to put in the calculator because I don't want to waste time anymore. How about fewer than five of them feel lonely? What's the low for? I think I'm, let me just look at this. Okay, if it says fewer than five, what's the low for fewer than five? Yeah, it's zero. Because zero is the lowest number that's fewer than five to feel lonely. What's the high? Yeah, it's four. Notice not five. Five is not fewer than five. So you got to read it's a very common mistake is to not read the words. And trials and P are the same. How about exactly five? What's the low for exactly five? Five. What's the high for exactly five? Also five. Same P and same trials. Any questions on this before I move to chapter five? All right, now we're going to go to continuous distributions. Okay, remember what we were finding was expected value and probabilities. Probabilities are much harder mathematically when it's continuous. Okay, so the first thing you cannot make a table of values and their probabilities with continuous variables. Instead, what you do is you can draw a probability distribution, not a table, but you can draw a graph. And for example, if you want to find out the probability that it's between 1.8 and 2.75, you look at the graph and you say, what is the area under the graph between those numbers? Okay, and this is an example, this picture, by the way. What shape is this picture of this graph? Do you remember in one word? Okay. Bill is a word that we don't use in our class. Remember, I told you there's a different word we're going to use because it's more scientific. It's an easy word. Not unimodal. It is unimodal, but that's not the special graph. There's lots of unimodals. This. Okay, if you don't remember normal, do you remember normal? There's a normal curve. Now, to find the area of this, if you had to do this by hand, let me ask you, say yes or no. I have had at least a full year of calculus. Yes or no? You've had at least a full year of calculus? A few of you? Okay. So I want to let you know what you would need is you would need at least a full year of calculus and you would need Kleenex because you'll be crying so much. Okay, so the answer is we're not going to do this by hand. No, I didn't mean me, I meant you all. And my guess is most of you haven't had a full year of calculus. Okay, so would be really hard to do by hand. So we're not going to do this one by hand. We're going to do a different example, and that is going to be the uniform distribution. So the uniform distribution from A to B, those are two numbers, is a distribution such that any two given intervals of length k that is contained in A to B has the same probability of occurring as any interval as any interval as any other interval. Okay. And then outside of AB, you have a zero probability. So the shape of the distribution of its uniform is a rectangle. Okay, and this is very important. The way I want you to type this. When I say write down the distribution, and it's a uniform distribution, I want you to write the variable, which is usually x. And then you may or may not know the word for this symbol. It's funny, a lot of you like speak Spanish, but for some reason, even Spanish speakers don't know how to say this. It's that little thing over the ñ in Spanish. And what we call it is a tilde. Yeah, look, someone knows it. It's a tilde. Okay. And it's shift, and it's the thing that's the key next to the number one on a keyboard, by the way. And then U stands for uniform, and then parenthesis, and then the low, comma, and the high, and then end the parenthesis. If I say write down the distribution, and it's a uniform distribution, this is how you need to write it. Any questions on that? And we'll do an example. Okay, so suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. So the first thing is we're going to write down x, that's our variable, and then tilde u for uniform, parenthesis 10, comma 120, and the parenthesis. Any questions on how I came up with the way of writing the uniform distribution for this example? Any questions on the notation? Okay. So now we have a question. If a randomly selected student who used a math tutor is observed, find the probability the student will spend between 30 and 70 minutes with the tutor. Any questions on what the question's asking for? Students spend between 10 and 120 minutes. If some randomly selected student comes in, what's the chance they'll spend between 30 and 70? Right? They might spend more, they might spend less, or maybe they'll spend in between. And we want to find the probability they're going to spend in between or between 30 and 70 minutes. Any questions on this idea? Okay, so the first thing you do is you draw a picture. A uniform distribution is a rectangle. So I'm going to draw a rectangle. And the low of the rectangle is 10. The high of the rectangle is 120 because that's the lowest number of minutes that ever get spent is 10 minutes. The highest is 2 hours or 120 minutes. So that's why I put 10 and 120. Then the rectangle has a height. Most people call the height h. That's standard. Makes sense, right? Let's find the height. Well, it's a rectangle. Who remembers the formula for the area of a rectangle? This is a pretty easy formula. It's probably the easiest area formula. Square might be easier, but rectangles are the next easiest. So who remembers the area for a rectangle formula? So what's the area of a rectangle? How do you find the area of a rectangle given the dimensions? Maybe you could type in the chat box. Somebody's got to know. Something you learned probably in 6th grade. Okay. Okay. So length times width times height. I think you're thinking about not a rectangle, you're thinking about a box, 3 dimensions. So it's not length times width times height. Yeah, it's length times width. I tend to not like to use L times W because L looks too much like a 1. And then it's really confusing. So I tend to use base and height instead of length and width. If you want to use length and width, that's fine. but L looks just too much like a 1. So I use base and height and then B and H. So what we can say is that the area is B times H, the base times the height. Now the area of the rectangle is going to be the probability that a student is going to spend between 10 and 120 minutes with the tutor. But if everybody spends between 10 and 120 minutes, that probability is 1. So the area is a base times height, which is 1. Does that make sense? So now, what is the base of this rectangle? What is the base of this rectangle that we have up here? How how do I measure it? The hint is I gave you the numbers. What's the base of the rectangle? Not a trick question. This is not supposed to be hard. Yeah, 110. I'm going to actually do the math. It goes from 10 to 120. So if I want the base, I'm going to take 120. Then I'm going to subtract 10. And that'll always give you the base. The height, we don't know. That's H. Now 120 minus 10 is 110 times H. Let me just rewrite equals 1. So if I want to get H by itself, I divide by 110 on both sides. And I get H is 1 over 110. Any questions on the kind of the basic geometry and basic algebra? Nothing too fancy. Okay, now we want the probability that a randomly selected student will spend between 30 and 70 minutes. So now I'm going to draw this picture with the 30 to 70. Now that I have my H. Okay, so the probability that X is between 30 and 70 is a base times a height. Now what's the base? How do I find the base of the rectangle? Of this shaded in rectangle? Not a trick question. This is supposed to be easy. How do I find the base of this shaded in rectangle? Yeah, I go 70 minus 30. And the height was 1 over 110. So what we get, 70 minus 30 is 40. 40 over 110. Okay, and I'll let you stick it in the calculator if you want. 4/11ths if you want to simplify, but you can stick it in the calculator and get as many decimals as you want. And that's the probability. All right, next, let's find the first quartile, Q1, for the time the students spend with the math tutor. Who remembers the definition of the first quartile? It's very important. That's going to be part of your project, by the way. You're going to have to interpret it and talk about how the client's going to use the first quartile. But who remembers the definition of the first quartile? I'll see y'all jumping in. Maybe I should give you a reminder. What that means is that there's the first quartile means there's a 25% chance of being below it. So 25% is less, 75% is bigger. So here's the picture of the first quartile. That means 0.25 will be the probability of being less than some value. Okay. We don't know that value, so I'm going to call that value X. So the X is down here. That's the value. That's how many minutes someone spends with a tutor. 0.25 is a probability, and that's an area. Any questions on that? So now we can use our formula, the area, which is 0.25, is the base times the height. The base now is the high minus the low. The high we don't know, that's x, minus the low, which was 10. The height was 1 over 110. Let me rewrite equals 0.25. Now I can multiply both sides by 110. We're going to do some algebra now. Nothing fancy, but algebra. We get x minus 10 is equal to 0.25 times 110. And if I want x by itself, I just add 10. So I get x equals 0.25 times 110 plus 10. And then you can stick in a calculator to get the first quartile. Any questions at all on these examples? Okay. I want to give you that, warning or heads up that watching me do it is not the same as doing it yourself. Make sure you know how to do it yourself. Okay. Watch me do it and then do some other examples. And you're going to have to do some on the homeworks, on the chapter 5 assignment. There'll be some of these kind of problems. Okay. Let's do another example. Statistics instructor will be giving extra credit to students in the top 8% based on how long they spend with a math tutor. At least how long must a student spend with the math tutor to get extra credit? So we do the same thing. I think I can make this a little bigger so you can see it better. All right. Well, the top 10%. Okay. That means 92% is below that number. Sorry, top 8% means 92% is below that number. Because 100% minus 8% is 92%, or 0.92. That's the same idea as base times height. The base was x minus 10. The height was 1 over 110. The idea is I made it this way so it looks just like the quartile question. And then we just do exactly the same thing. We multiply both sides by 110, and you get x minus 10 equals 0.92 times 110, or x equals 0.92 times 110 plus 10. Okay, I don't have time to do all these other ones, but I want to get to the last piece that we need to do. Okay, because we only have about 15 or 16 minutes left. I want to make sure we get this. All right, so if we have a uniform distribution, then it's going to have a mean and it's going to have a standard deviation. The mean should be easy. Let me show you the picture. So here's a uniform distribution example. And because everything's symmetric, the mean will be the same as a median or right in the middle. How do you find the middle when you know the left and the right? How do you find the middle or the median? You divide the base by 2. Not quite the base. So we're not going to take 120 minus 10 and divide by 2. Close, but not quite that. Okay. So what you do, I don't see y'all jumping in, is you add the high and the low and divide by 2. Okay, you would take 10 plus 120 and then divide that by 2, and that'll give you right in the middle, which would be 65, by the way. Does that make sense? So the formula is the mean is A plus B divided by 2. Any questions on that idea? All right, the standard deviation. Okay, I will let you know if you haven't had your year of calculus. Good luck. So I would never expect you to prove this unless you decide to be a math major, and then you should know how to prove it. But what I do want you to do is make sure you understand it, and that is the standard deviation, sigma, is the square root of b minus a squared over 12, and it's all inside the square root. Okay, and this is one of those where trust it. Okay, I could prove it for you, but you would all be lost, or most of you would be, anyone who hasn't had calculus. So, but it just is. So it's a formula. Any question on this? All right. So now here comes an example. Suppose that the number of ounces of water people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces, and the number of ounces of water that students use to fill their bottles in the drinking fountain. Here we go. This has water in it. So the idea is I drank a bunch. And I say, I think I want to fill it now that I've drunk some so I don't, run out later. And so always going to be the exact same amount. But let's suppose that that is uniformly distributed, okay, between 4 and 16 ounces. Okay, now you watch Thorne take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Okay, whose water usage is more unusually small compared to the rest of people who use the fountain for the corresponding water usage? Any questions on what it's asking? Any questions? Okay. So now I have a question for you. Let's see if you remember. How do you measure how unusual something is? We did this in chapter 2. So it has been, week and a half or so. How do you measure how unusual something is? Whenever I ask something that's been more than a week, people go, oh, I don't remember, but you need to remember. For example, next week's test, it could ask this because everything is, you're supposed to remember everything or at least have it down close to you so you can get to it. All right, give you a hint so I don't see anyone guessing. I want you to answer with a one-letter answer. So if you have no idea, you have a 1 over 26 probability of getting it right. But hopefully you have an idea. How do you measure how unusual something is? Should be very quick to type. It's just one letter. Yeah, Z. Yeah, you get the Z score. Okay, Z will tell you how unusual something is. And if you remember Z, the Z score is X minus mu over sigma. That was the formula. Do you remember that? So what we need to do is we need to find Thorne's Z-score and we need to find Preston's Z-score. By the way, Thorne and Preston, many, 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 many years ago, took my stats class. They were nice people. Okay, so Thorne took a 2.5 ounce drink out of the drinking fountain. So X, that's the value that happened, is 2.5. Okay. Now, Thorne was out of the Thorne, if you look at it, was just drinking. Okay, and just drinking is uniform distributed between 1 and 8 ounces. So the mean for just drinking is 1 plus 8 over 2, A plus B divided by 2. And that's 9 halves or 4.5. The standard deviation will be B minus A quantity squared over 12 and take a square root. So 8 minus 1 quantity squared over 12 and take a square root. And that would be hard to do by hand, but it's about 2.02. Any questions on that? Any questions? Okay, so now we can calculate the z-score. The z-score is x, which is 2.5, and then minus mu, and mu was 4.5, divided by sigma, and sigma was 2.02. Okay, and if you take 2.5 minus 4.5 and divide by 2.02, you get something very close, approximately -1. Okay, at least to 1 decimal. Then we do the same thing with Preston. Okay, Preston filled his water bottle with 5 ounces of water. So Preston has his x as 5. And for water bottle filling, that's uniform between 4 and 16 ounces. So A is 4 and B is 16. So Preston's mu is, or the mu for water bottle filling is A plus B over 2, which was 4 plus 16 over 2. 4 plus 16 is 20. 20 over 2 is 10. That's an easy one to do in your head. Okay, sigma is the square root of B minus A squared over 12. B is 16, A is 4, so it's square root of 16 minus 4, quantity squared, over 12. And that one, good luck if you wanted to try to do this in your head. It's not going to happen, but you can use a calculator, and you get about 3.46. Any questions on that? Okay, so now we can find the z-score, which is, again, x minus mu over sigma. Preston's x was 5, so that's 5, minus Preston's mu is 10. And then sigma is 3.46 for Preston. So that goes right here. So you take 5 minus 10 divided by 3.46. Okay. I want to give you a heads up. It's a common mistake people make. If you type in the calculator, what's wrong with going 5 minus 10 divided by 3.46? Why is that going to give us the wrong answer? If you put that in calculator, including computer calculator, any calculator. What's wrong with doing that? So again, I always like to give heads up on mistakes a lot of people make. Why is that wrong? It's a common mistake. It may divide wrong. Okay, that's might be what you're thinking. I mean, you might be thinking what's right. It's hard to read your mind. It's order of operations issue. So order of operations says if you just write it out like this, it's going to divide before it subtracts. And because we have this 5 minus 10 in the numerator, you need to subtract instead of divide. So this is wrong. Instead, you need parentheses. 5 minus 10 in parentheses divided by 3.46. And that way, remember, order of operations, PEMDAS, they call it sometimes, says parentheses first, and then it'll do the 5 minus 10 and then divide by 3.46. Okay? Does that make sense? So again, I always like to, stop the mistakes before they happen. So hopefully you don't make that mistake now that, you've been reminded. Okay, so we get negative 1.45. Okay? So now we can answer the question. The question was, whose water usage is more unusually small compared to the rest of the people who use a fountain for the corresponding water usage? Whose usage is more unusual small? Now that we have the two z-scores. Who is more unusually small for water usage? Yeah, Preston. Okay, Preston's number is smaller, negative 1.45. Let's write this down. Negative 1.45 is less than negative 1. Okay, it's very important to know that. Okay, it's farther from 0 on the left. So, oops. So Preston water usage was more unusually small. Was Preston an outlier, by the way? Okay, the answer is no. No, no, no. Outliers have to be less than negative 2 or greater than 2. And Preston is negative 1.45, which is not less than negative 2. Do you see? So there's no outliers in neither Thorne nor Preston are outliers. Okay, very important for your project, by the way, because you are going to be required to see if there were any outliers and then interpret and, talk, tell the client what decisions they might make based on outliers, if there were or weren't, and what they might do about it. Okay, any questions on this? Okay. So secret word. The secret word for this webinar is discrete, because again, chapter 4 is all about discrete variables. Okay. So it's important that you understand that word. So discrete is the secret word for this webinar. Make sure you know how to spell it, write it down. Okay, so that's the secret word. So again, I want to strongly recommend you start working on the project. Okay, if you procrastinate, things go badly usually. Okay, so that's important. I'm here to help you. And so are the tutors, by the way, they can help too. Okay, and we can definitely all help you on the project. But again, please post your project idea on the Project One discussion board so I can let you know if it's going to work or not. And if it's almost going to work, what changes need to be made. Are there online tutors? Yeah. Yeah. If you go to the library website, I do want to let you know there's been some issues with the college website today. So don't start crying if the website dies. But this morning it was completely down. Kind of sucked. But hopefully they'll get it back up. Don't get mad at me for that. It was not my fault. Okay, so that's pretty much it. It's 7:31. I always like to end around 7:30 and where we are. But I'm always happy to answer questions. I'm going to stop the recording. And again, thanks for coming, and then I'll answer questions.